Hello, I am Kaixun Tim Cheng, and this is my first video for EduFlite series. Because this is my first video, in this video we are going to have a 5 minutes. Spend the first roughly 5 minutes talking about what we have done about the background of the project, and then we are going to spend more time to look at the actual programs that I have done so far, and then as I am progressing on it. Now, EduFlite series started originally as a drone, just a standard homemade drone that's not even a racing drone last year. It's just like so last year I figured it's going to be cool for me to build myself a drone, because it's cool, and then I did decide to actually design myself a drone. Now, it does not look very good. It just doesn't. It's like this wingspan. It's the same wingspan as the. I'm honestly not even sure if wing is the right word. It's like the arm span. It's the same arm span as the final design, but it's like 3 times taller. So it's gonna look like this. And then of course it's not very good as a drone. But I didn't really think about changing it because I just honestly don't know how. And then one day my friend came up to me and I was like, "Hey Tim, how about you build this thing into a racing drone? It's basically the same electronics, the same motors, the same ESC, the same battery. Just make it a racing drone because it's cool, But then you have FPV anyway." I was like, "Man, wasn't they really design? I didn't really design it to be a racing drone, And then he was like, "Yeah, all right." But then later on, I actually thought about it again, and I actually think his advice is actually valid. I mean, it's the same electronics, the same setup. Just it's like it can't even be the same wingspan. It's just like I can change the CG a bit, and then I become a racing drone. That's good, man. I mean, that's good, right? So I did, and then that's the EduFlite. I have designed my most recent version of the EduFlite I designed, and then I can show you guys what the one before looked like. It does not look very good. But probably not in this video. I'm in Linux right now. So yeah. And then when I started this last year, I didn't really I wasn't really thinking about making open source then, I mean, it's just I thought it's something that I can just do it, and then I can just have it to myself, and the only reason I was wanting to do it is because I thought, hey man, it's cool. But then I was still learning a lot when I was doing it, because it's like working on the electronics, working on the power supply. You know how the drone's power supply work, right? It's like really hand ampage. And then from that, I realized I actually learned a lot doing it, like the communication protocols, gyroscopes, the actual interaction between all the chips that you can have in one electronic circuit, the microcontroller, the PID controller, all of that. And then so I thought, hey, I consider this something cool, and there will be other people who consider the same as well, right? I mean, because I have heaps of program. I have quite a few friends who actually who are interested in the STEM field, but they don't actually know how to get started. They don't really know how to get better, all of that. So I thought, hey, maybe this is a good place to start, because it's cool. We can get their passion on and all that, and then I can actually make it open source, and I can even write a tutorial about it, like this. This is literally what this is, and then it can make life easier. So to get more people into STEM, it's literally it's just a really important job, to the world and to humanity. I mean, it's a big topic, but I believe this job is one of the things that's really important to the progression of humanity. I mean, I know people who disagree, who can disagree, but it's fine. That's not really a point I'm gonna argue about, right? Just so and then as I said, I started working on this last year, so I did have a bit of progress done already. So actually, the thing is, I designed that huge, tall drone that runs on 4S with 2:1 2 motors and clearly just isn't gonna check out that well. And then I think, and then Charlie told me which is my test pilot, by the way. He told me, "Hey Tim, why don't you build a racing drone?" And then so I redesigned the model to actually make it kind of a RC FPV racing drone, like. So I changed the mechanical design, and then I changed the electrical design because that one's power supply track is a little thin. So like when you have exposure, when you have like a huge amount of current running through something, like in this case 40 amp, burst 80 amp, continuous 40 amp, So like in a situation like this, it is actually very, very important to actually have a track thick enough so that you can actually conduct the current. Else when the track heats up, and then like when the printed circuit board actually heat up to a particular point, it will actually start to peel off. It's disgusting, I know, but it's just annoying, disturbing. I know, but nobody likes it, okay? But it's what happens, and it's a part. Like it is a result, an inevitable result of the current printed circuit board manufacturing process, which is not something that we can actually complain about. So yeah, so I already designed the electronic circuit, and then I move on to program. I've done program before, and it actually kind of works. But the thing here is, you see, that one it just doesn't look good. Okay, it just doesn't look good. Like, it looks real bad. It looks like just ugly. So I decided to rewrite my head-up display and they rearrange the graphical user interface, and then that's actually what I'm doing right now. So I'll catch you guys up later with the electronic and the mechanical design. It's pretty simple stuff, right? Because I'm aiming to get more people interested. I'm not really. My purpose here isn't scare people off. So it's not really that hard stuff. It's like once you get your head around it, it's understandable. And then about the program, it's the same thing. It's just like I just got the idea of starting to record, so I figured, hey, maybe I can I actually thought about to finish my current program before I actually start video, but I was like, maybe I can just start it, halfway. Now this one is it's an experiment I'm doing about the display. So I'll see. So I may this is just like an experiment. Like I can write the program, I show it up on my screen with nothing else, just to see how this one works on its own. It's not even about the bugs. It's just like how it looks. And if this one works, I know this is the look. So I put it into a header, and then well, of course, if this one has any bugs, so it doesn't run, I'm gonna do a bit of a debugging. But yeah. Most of the debugging process is actually going to happen after the program is complete. So this one is only a teeny little part of it. Yeah. So So what this is actually my first anything I wrote in my refreshed let's say remastered version of the terminal software. The Raspberry Pi side of the software is basically the same because it has no graphical user interface. The performance is acceptable, and it's basically it. I mean, it's gonna be an update later on using GPU instead of CPU for encoding WEBP, instead of JPEG to save a bandwidth and extend the range, but not before I complete the minimum viable prototype, and probably not this year. Okay. So let's make myself smaller so I don't get in the way of my code, and let's see how this works. 1 second. My parents is playing with playing with their bird. It's not my bird. My parents playing with their bird, so I figured it's a good idea for me to close my door. So this one is the pitch side experiment. So pitch side is a part of the head-up display, and I'm gonna show you where. I'm sorry if I look tired. It's just I'm not very used to video recording, and I'm having trouble controlling my breath. Hold up. Better. Now, if you are able to notice, I'm not really in Windows right now. Just because of to my personal opinion, on developing a software like this, it's just easier to work it out in Linux instead of Windows, because especially when your program is heavily based on third parties. I mean, there are cases where you can only use Windows. In some cases, like video game and that kind of stuff, it's not really necessary you have to use Windows. Just there are cases where you have to consider the consumers, the potential users of a software might prefer Windows. But in other cases, it's not necessarily happening, and in this case, I just find it way easier to develop, debug things in Linux, and I'm facing the people I want to. This thing is mainly facing the people that want to learn, and especially as a beginner, it's way easier to work things out in Linux. Trust me on that. It will take you some time to get used to Linux, but once you get used to it, it's so easy. For example, in Windows, if you link the this one uses OpenCV, right, to convert the format of the image. So in Windows, you need to set up the Visual Studio manually and all that. In Linux, you just go sudo apt get install OpenCV dev lib OpenCV dev, and that's it. That's how easy it is on Linux, and then on Windows it's half an hour, 1 hour process, maybe. I don't know. Yeah. So let's go through the program about what I have done already. So these ones are the headers that you are to include. All of these ones just you have a function you want to use, and you go up to the internet, you search up, hey, what library is this function, and the internet tell you, hey, this one is in OpenCV, this one is in SStream, this one is in cstdlib, and then just to explain to you what's going on here, I actually write myself a little from the previous version of my terminal software, I wrote myself a easier display header to actually allow you to display a OpenCV mat directly to a screen. This is pretty bad. Last year, this is I wasn't really exactly thinking about the professionalism of the program, right? This is really bad practice here, so try not to copy that. I'm gonna change it later on in later episodes, but today we're not focusing on this. I mean, these ones, it's fine if you're just experimenting with things, but in the header, try to leave this out. And because this is header, I'm gonna change this later on. But I wrote this one when I was 15 years old last year, so please forgive. And then so we have using namespace, which is a very lazy way and very unprofessional, and I'm going to fix that later on, but not right now. Okay, so we know the pitch is You know, like this. And then for the drone, it's like going, rotating forward and rotating backward, if that makes any sense. Like, because it's 3-dimensional, I can't use clockwise and anti-clockwise, right? So the minimum pitch is like towards the other side of the original, which means your propeller facing directly down, which is negative 180. And the maximum pitch, on the other hand, is actually kind of the same. 180 and negative 180, wait. Yes, I think they're the same thing. Yeah, they are the same thing. Yeah, they're the same thing. So negative 180 and 180, like they have 360, which is a rotation. Forgive me for not using radians. It's like, when controlling this, especially when we are controlling this stuff, we're so used to degrees, like, it just doesn't make any sense to put a radian on it, right? I know if we are going to physics and stuff, radian is a good practice, but here we're in degrees. Maybe I should comment on that. And then we have show range, which is the actual range of the showing this section of the head-up display. And then show range is just the how many degrees is shown in the entire thing. I'm gonna show you guys what I mean. So like before this, I did a bit of a display planning here. Over here. And I've got a 2 resolution. I've got a plan for 2 resolution. And the I'm sorry, I'm really not used to talking like this. Yeah. So this is the actual HUD pitch side. So here you're gonna, so the plan here is, this is gonna be the title. This is gonna be a value, numeric value, showing you what your actual pitch is. And then in here it's gonna be like a scale thing that has some bars marked with numbers telling you where the closest 10 degree is, and then a triangle right here in the middle showing you where the center is, which represents your current reading. Excuse me. Yeah. So show range just means your thing here in the middle is 80 degrees in total. So from top to bottom, that's 80 degrees. And so define low resolution false. So this one is for computer screen. That so if your computer screen is below 1080p, makes this one true, and if your computer screen is 1080p or above, makes this one false. So your computer, so this thing can run a high resolution. By the way, high resolution does mean higher bandwidth, but I'm gonna do a feature in a video encoding later on to actually let you choose the bandwidth when you are, to let you choose the actual image resolution when you are in high resolution mode, so that it comes more handy, you know. But yeah, that's a problem for tomorrow. But that's a problem for later on, not today. And then we're defining some basic features here. So for example, in low resolution mode, the width is 160, which means from here to here is 160, and from here to here is 480. And there it is. Display title height just means, 1 second. Display title height is a reserved space to put down your title. Which is, you know, like how say there's gonna be a text box here writing your title, there's gonna be a text box here writing your value, and that's what it is, you know. Font face, font scale, thickness, font face, font scale, thickness. This is the OpenCV writing. I might go in that a little bit more detail later on, and I might tweak this a little bit so you guys can see, but not today. Oh my god, I really need to catch my breath. Sorry, just 1 second. Okay. Now, for instance of the bar, you remember bar, like by bar I mean the marking in the section, PHUD, HUD every 10 degrees. Bar is the closest word I can find. I mean, like, I really don't know what's a better word for bar in this scenario, you know. If you have a suggestion, tell me, but I'm probably not gonna change here. Like in programming like this, when you write something down, it's there. It's very hard to change later on. I mean, you can change it, but you don't have to this one. And then get bar text, it's like there's gonna be, you know, like this vertical line here and then horizontal bars here and there. And you know, like the bar have a lens, then it's gonna make text on the side. But like if they all jammed up together, like you just can't see the text properly. Just to prevent that, we leave a bit of a few pixels between the bar and the text, so that you can actually see it. So you can actually see the text properly. I apologize. Okay. And if it is not low resolution, then it's high resolution, so everything is on a bigger scale, but it's basically the same thing. Alright, so main function. Now in the main function, I may so like I'm not sure, like I believe some of you guys listening to my video here will be having a lot of experience in programming already, but some of you could potentially be relatively new to the field. So I'm gonna spend like a minute or two just very briefly explaining how program works, like in C++. So when you're writing it, you have an entire bunch of functions. You have an entire bunch of classes, an entire bunch of variables and arrays. And then your main function. Your main function is not in any of the your main function is not in any of the classes. Your main function is not in any of the what's it called? Types. Your main function is just a function individually sitting out on top of everything else. And then below that, you'll have classes. Now actually classes itself is in the parallel level of that. But a main function can tell a class what to do. So it can call the functions in the class, and then it can manipulate the variables in the class if in the class you set the variable and the functions to be accessible by the main function, which means public. So from that, what you actually do is you write all your functions, like what you wanted to do in particular, and then every single thing that you wanted to do, like every single type of things that you wanted to be dealing with, you write a class. So every type you write a class, and there are a few functions for the specific things that it's gonna do. And then you have a main. Now, when your program is being executed, the compiler go find your main, and then your main just can be like your main is more like in a good program. A main can roughly be a few T lines of code. In some cases, maybe a few. But in a good program, the main function rarely goes over 100 line, and everything else goes into your headers. So yeah, like once in a while when C++ was a really fresh thing, and then like when C was actually a really fresh thing, and everyone else was crazy about it, and then they saying only the top scholars, the smartest people in the world can learn it. They were really this time, like right now we can see that just like anyone, if you put a mind to it, you learn. But back then, like people just saying it's a crazy, it's mysterious stuff, only for smart people. And then at that stage of time, the people who actually learned how to program. One second. They tend to jam their programs. Everything in the main were a few functions. And then in the end, they just look at stupidity, and then nobody else will be able to understand it. Even themselves, looking at it a few years later, they wouldn't even be able to understand it. And then it just makes the entire code impossible to maintain. So, and then that's the reason there actually later on became a saying called like a good habit during programming. I'm gonna go into that a bit later on. But I don't really think, but like just briefly, because like you guys can see what I'm doing, and I will try to keep myself to the best behavior on this project. I'm actually trying to keep myself on best behavior on every single one of my projects right now, because my habit of programming last year was kind of just like undesirable. I mean, it's still readable, but like I've been making mistakes that are very newbie. We all newbie once, like that's not a problem. Like if you don't know much about this, if the person you sitting in front of the screen looking at my video doesn't really know much about programming or electronic design or engineering at all, it's completely fine. Okay, it's completely fine. I mean, I was once a person who literally knows nothing about any of these. I mean, I didn't learn anything about electronics until I was like 13. I mean, 13, 14, 13. Yeah, I mean, before that, the only electronic I did was like electronic Lego. And you know that's for kids when I was like 5 or 6. And then programming, I didn't really know anything about programming until I was like 9, okay? I mean, if you are like 15, 16, 19, 18, and then you are really into this, it's still understandable. Give you some time, with the knowledge you have, you can be very good. And probably even better than me. I mean, I'm not really that hard to actually exceed. To actually like, what's the English word for this? Comment below for to actually give me an idea. English is my second language, please understand that. Okay, so let's go into the main function. Now, you have a CIMG display, and this is actually the library I write. And then you go initiate, so set the size for the screen. This one is for low resolution. I'm gonna change that to higher resolution later on. I'm just right now briefly go through with you guys what I've done already, and then I'm gonna take a break. Okay, it's shooting a video is like killing my throat. Okay, now. And then you have a current pitch, which is what this thing is going to display in the very beginning, which is very, very important. And then you have a string to convert, say, float value to std string value. Right? And then you have a reference triangle. Do you draw upper reference triangle and do you draw lower reference triangle? Now in this one, I'm thinking about a on zero marking on the left side. So the reference horizontal will actually draw a little triangle here to actually remind the pilot you are at the actual horizontal, which is a standby location for, which is like the standby in the air, not moving location for the drone. Excuse me. Okay, better. Now, OpenCV, the rendering in OpenCV is based on points. Now, on my points, it's just a location, relevant location to the left top side of the left top corner of the mat. It's a relevant position in pixels from that location. So you have an x-axis and a y-axis. The y-axis goes up when the point goes down. So it's opposite of what you learn in math. Okay? Keep that in mind. It's going to be very important later on. Always get that straight. This is graphical design. It is not mathematics or physics. When you get confused, it's gonna look real funny, and you don't want that. I mean, it's not bad. You can just change it later on, always. But yeah, if you can get it right in the first place, get it right in the first place, right? So I think I'm yeah. I just need a break, you know. Okay, better. So you have the size. Size is the dimension in pixels, horizontal and vertical. It's called width and height. And then we are going to use the size of the title text box. Remember, it's not actually a title text box. It's just a title writing. Okay, so you're gonna need the size of the title writing and the size of the value writing. So the thing that goes on top here and the bottom here to actually calculate what the original of these are, the original point of these are, so that they are right in the center of up here and down here. Alright, nice and easy. And then there's gonna be some marking on the side, so we need to know how big they are to actually find the correct location for them as well. Yeah, I think, yeah. You know what? I'm gonna take a break here. Like I need a breathe. I need a drink. I need some food to eat, and I'll see you guys back.